No, I know that word efficiency can sound like the most boring corporate buzzword imaginable.
Oh, absolutely. You hear efficiency, and you think of some consultant in a cheap suit who's about to tell you to cut your department's coffee budget.
Right. That's the worst way to think about it. But looking at this stack of research, these articles, and all the notes we have today, this isn't about buying cheaper coffee. This is a masterclass in what's called operational systems mastery.
Mm,
It's about how you organize human effort, so that it doesn't just collapse under its own weight.
precisely. And what's so exciting about this particular collection of sources is that it treats operations as a kind of toolbox.
Hmm.
We aren't just looking at one single theory here. We're looking at a whole history, a whole evolution of how humans have tried to conquer chaos.
So it's not just one thing.
No, not at all. We've got lean, we've got just-in-time, Six Sigma, business process re-engineering. It's basically the greatest hits of getting things done right.
But that's also the problem, isn't it? It's a lot of acronyms, JIT, BPR, TPM. It feels a bit like alphabet soup.
It can be very intimidating.
Right. So if I'm a listener, let's say I'm a manager or an entrepreneur, or honestly, just someone trying to organize my own life, how do I know which tool to pick up?
And that is the absolute mission of this deep dive. The biggest mistake people make is treating these things as interchangeable buzzwords. They'll say, oh, we need to be more lean, when what they really have is a quality problem that needs Six Sigma.
So they're using a hammer when they need a scalpel.
Or they try to use a wrecking ball when they just need a screwdriver. Our goal today is to sort through these methodologies so you know exactly which one fits the specific problem you're facing.
I love that. So let's start with the blueprint. The source material uses this visual of a building, this architecture, to structure everything. It says you can't just jump to the penthouse, you have to pour the foundation first.
Right. So let's start at the ground floor. Level 1, this is the foundation.
And in our sources, the foundation is labeled philosophy, specifically the philosophy of lean.
Correct. Before you can build anything fast or complex or perfect, you have to first stop doing the things that are actively destroying your value. It's addition by subtraction. You have to identify and ruthlessly eliminate waste. That is the core of lean.
Okay, so level 1 is just cleaning house, getting rid of the junk. What's level 2?
Level 2 is mechanics. Now that you stop wasting time and energy, how do you make the actual work flow? How do you create stability in the system? This is where we find the engine of the operation. Things like just-in-time, JIT, the 5S framework, and TPM, which is total productive maintenance.
Got it. So we've cut the waste and we've built a smooth running engine. What's level 3?
Level 3 is precision. This is where we stop guessing and start measuring everything. We're talking about reducing variation, tiny little inconsistencies through heavy-duty statistical control. This is the world of Six Sigma. It's not enough to be fast anymore. You have to be right every single time.
And finally, what's on the top floor? Level 4.
Level 4 is reinvention. This is the, let's call it the nuclear option. This is for when the building itself is the problem. It's no longer about renovating, it's about demolition. It's radically redesigning processes for quantum leaps in performance.
And that's BPR, or business process reengineering.
That's BPR.
Philosophy, mechanics, precision, reinvention. Okay, that's our roadmap. And I want to be really clear to you listening. We are going to challenge these ideas because some of this stuff, especially when we get into JIT and concepts like zero inventory, it sounds great on paper, but we all just lived through the last few years. We all saw what happened to the global supply chain. That zero inventory idea seems a lot more fragile now.
Oh, absolutely. These are incredibly powerful tools, but they are sharp. You can cut yourself badly if you aren't careful. There is a massive tension running through all of this material between waste elimination, which is generally steady, safe, and incremental, and radical redesign, which is explosive, risky, and can blow up in your face.
All right, let's put on our hard hats. Let's head down to the foundation, level 1, the philosophy of lean. Now, I have to stop you right at the definition because when I hear lean, and I really think most people are with me on this, I think layoffs.
Yep, that's the immediate association.
I think doing more with less. I think of a stressed out team being told they have to be leaner, which is just code for work harder for the same pay.
That is the absolute tragedy of how this term has been co-opted over the years. If you look at the source material and you go back to the history of where this comes from, Toyota in the post-war era, mostly lean is absolutely not about making people work harder. In fact, it's the opposite.
So correct the record for us. What is it, really?
Lean is a systematic, organized method for eliminating waste without compromising productivity. And the core distinction, and if you only remember one thing from this section, this is it, is the difference between value-adding steps and non-value-adding steps.
Value versus waste.
Right. A value-adding step is any activity that physically transforms the product or service in a way the customer is actually willing to pay for. It moves the needle forward. A non-value-adding step is literally everything else.
Okay, give me a concrete example, and let's step off the factory floor for a second. Let's say I'm working in an office, a typical corporate job.
Perfect. Imagine you need to get a new project proposal approved. You spend 3 hours writing a brilliant proposal. That's value. The customer, in this case, your boss, needs that information. That's a value-adding step.
Okay.
Then you email it to your manager. It sits in their inbox for 2 days because they're busy. That's non-value-adding. Then they finally open it, spend 5 minutes reading it, and sign off. The 5 minutes is value. The 2 days were waste.
And then it goes to their director.
Exactly. And it sits in the director's inbox for 3 days. More waste. Then it goes to finance, who has to cross-reference it with a budget code, and that takes another day.
I'm getting frustrated just listening to this hypothetical.
We've all lived it. The value in that whole week-long process was maybe 30 minutes of actual work. The other 4.5 days were pure, unadulterated waste. The customer doesn't care about your internal sign-off hierarchy. They don't care that your director was on a golf trip. They just want the result, Lean says. That waiting time is a crime against efficiency.
So historically, this came from Toyota looking at American-style manufacturing and thinking, there has to be a better way. The sources mention this term batch and queue.
Right. Batch and queue is the old way. Think of a bakery that only has one big oven. The baker decides, okay, from 8 a.m. to 11 a.m., I'm making muffins. So they make a giant batch of 500 muffins and pile them up. That's the batch. They sit in queue.
A mountain of muffins.
A mountain of muffins. Then from 11 a.m. to 2 p.m., they make a giant batch of 500 cookies. If a customer walks in at 10 a.m. and wants a fresh cookie, what happens?
They're out of luck. The system is clogged with muffins. And those muffins, by the way, are getting stale while they wait.
Precisely. The inventory is going bad, and the customer is unhappy. Toyota flipped this to what they called product-aligned pull production. You make a muffin, you sell a muffin. You make a cookie, you sell a cookie. The customer's order pulls the work through the system. It sounds simple, but it requires a complete rethink of how you organize work.
The source material lists 5 very specific features of Lean. I want to run through these because some of them sound, well, pretty radical.
They are. They're ideals.
Okay, number 1, 0 waiting time.
The goal is that nothing ever sits idle. No idle hands, no idle machines, and most importantly, no idle product or information.
Number 2, 0 inventory. Now hold on. 0. We just talked about the supply chain debacles. If you have 0 inventory and a boat gets stuck in the Suez Canal or a pandemic hits or a supplier goes bankrupt, you have nothing to sell. Isn't this just incredibly dangerous?
It is extremely dangerous if you misinterpret it or implement it poorly. 0 inventory is the theoretical goal. It's the North Star you navigate by. In reality, of course, you need some buffer. But the Lean philosophy argues that excess inventory is like a drug.
How so?
It makes you feel safe, so you stop fixing your underlying problems. If you have a warehouse full of spare parts, you don't really care that your main machine breaks down every Tuesday like clockwork. You just sigh, walk to the warehouse, and grab another spare part.
Ah, I see. So the inventory is hiding the incompetence. It's a crutch.
It's the ultimate crutch. It hides inefficiency, it hides poor quality, it hides bad supplier relationships. Lean says, remove the inventory, lower the water level in the river so you can see all the rocks. When the machine breaks and there's no spare part, you feel the pain, and you are finally forced to fix the machine permanently.
That's a tough love approach to management. Okay, number 3, pull processing.
This is directly connected to inventory. You don't make a single thing until a real customer asks for it. You don't push product into the market hoping someone will buy it. The customer's demand pulls it from you.
Number 4, continuous flow. And number 5, continuous finding of ways to reduce process time. It sounds absolutely relentless, like you're never satisfied.
It is relentless. It's a culture of constructive dissatisfaction. You're never done improving.
Okay, so to do all this, you have to become an expert at spotting the waste. The source material has this fantastic section called the 7 wastes. It frames them as the villains of efficiency. I want to go through these in detail because I think everyone listening will recognize these from their own jobs.
Oh, once you see them, you can't unsee them. They're everywhere. These are the root causes of chaos in any system.
Okay, villain number 1. And the sources call this the boss villain, overproduction.
This is the big one, the original sin. It's producing more than is needed, sooner than it's needed, or faster than it's needed.
Why is this the root villain? I mean, if I make a few extra widgets, isn't that just being prepared, building up a little safety stock?
No, because it's the one waste that actively creates all the other wastes. It's a chain reaction. Think about it. If I make 100 widgets that nobody has ordered yet, what do I immediately have to do with them?
You have to put them somewhere, store them.
Right. So now you've created villain number 2, inventory. You need a warehouse, or at least a corner of the factory. You need shelves. You need a system to track them so you don't forget you have them. All of that costs money and space. But wait, how do you get them from the machine to the warehouse?
You have to move them. Forklift, a cart, something.
And there's villain number 3, transportation. You're now paying an employee to move stuff that nobody's even bought yet. And while your machine was busy making those 100 unwanted widgets, what wasn't it making?
The stuff that the customer actually did order.
So now that customer has to wait. And there's villain number 4, waiting. Do you see the domino effect? One bad decision making too much triggers a cascade of inefficiency.
It's a domino effect. It's incredible. One bad decision at the start pollutes the entire process downstream.
That's why the first commandment of lean is, thou shalt not overproduce.
Yeah.
Everything else gets easier if you can control that one impulse.
Okay, let's look at some of the subtler villains. This one is interesting. Motion. How is motion different from transportation? They sound like the same thing.
This is a really common point of confusion, but the distinction is critical. Transportation is the movement of the product, the widget, the file, the invoice. Motion is the unnecessary movement of the worker or the equipment.
Okay, give me an example.
Let's go back to our mechanic. If he has to move a car engine from one bay to another, that's transportation. But if his toolbox is on the other side of the garage and he has to walk back and forth 20 times to get the right wrench, that's motion.
It's the human movement.
Exactly. It's bending down to pick up a screw that he dropped. It's reaching for a tool that's just out of comfortable reach. Each one seems trivial. Oh, it's just 5 seconds. But if he does it 200 times a day, that's over 15 minutes of paid time where he isn't fixing the car. He's just walking and bending. That's pure waste.
And for us knowledge workers listening, the people sitting in offices, what is the equivalent of motion?
Oh, digital motion is rampant. It's one of the biggest productivity killers of the 21st century. It's clicking through 6 different subfolders to find a file you need. It's having to switch between your email, then Slack, then Microsoft Teams, then Zoom, then back to email.
The constant alt-tabbing?
That constant alt-tab switching is digital motion waste. Every time you switch context, your brain has to reorient, which takes time and energy. It breaks your flow state.
That hits home. I think I spend half my day just commuting between different software applications. Okay, next villain on the list, rework.
Rework from defect. This one is just painful. It's doing something over again because it wasn't done right the first time. You make a product, it's wrong, you have to fix it. Or worse, you have to scrap it and start over. You've paid for it twice, but you can only sell it once.
And finally, the 7th waste, overprocessing.
This one is sneaky. It's doing more work on a product than the customer actually values or requires. It's the gold plating problem. Like polishing the inside of a machine where no one will ever see it. Or in the office world, spending 2 hours formatting a spreadsheet with beautiful colors and intricate borders for an internal report that only you will ever look at again.
I feel personally attacked by the spreadsheet comment. I do love my color coding.
Hey, if the color coding genuinely helps you understand the data faster and make better decisions, then it's adding value. But if you're doing it just to make it look busy or pretty, and it adds no functional value, then it's overprocessing. It's waste.
Fair point. Okay, so that's the foundation. That's the philosophy of lean. We've identified the 7 villains. We know what to kill. Now we need to build the system that keeps the good stuff moving. This brings us to section 2, the engine of efficiency. And the big one here is just in time, JIT.
JIT, the definition is very strict. A pull system driven solely by actual customer demand. The mantra is, make what is needed, when it is needed, in the amount that is needed.
The source material has a great visual here comparing a push system to a pull system. The push system looks like traditional manufacturing. You know, process A makes a big pile of parts, pushes them into an inventory buffer, then process B takes from that buffer whenever it's ready. It's safe. There's a cushion.
It feels safe, but it's blind. In a push system, process A has no idea if process B is broken or slow or making bad parts. It just keeps dumping stuff into the pile based on a forecast. The pile grows. The problems are hidden under that mountain of inventory.
And the pull system.
The pull system works backward from the customer. Imagine a really efficient restaurant kitchen. The chef at the grill doesn't cook a steak until a waiter brings an actual customer order. The waiter's order pulls the steak from the chef. The chef's need for a raw steak pulls it from the butcher in the back. The demand flows backward.
And the result is no piles of pre-cooked steaks sitting under a heat lamp getting rubbery and tough.
Exactly. The product is fresh, and there's no waste.
Okay, but here's where my anxiety kicks in again. In a restaurant, if the chef runs out of steak, it's not great, but you just tell the customer, sorry, we're 86 the steak. In a car factory, if you run out of engines, the entire assembly line shuts down. You're losing millions of dollars an hour. JIT seems incredibly, terrifyingly fragile.
It is fragile, and in the lean philosophy, that is a feature, not a bug.
How can fragility be a feature?
Because the fragility forces excellence. It creates a state of creative tension. That's why the source material lists TQM integration, total quality management, as a mandatory feature of JIT. In a buffer system, if you find a bad part, you just toss it and grab another one from the giant pile. No big deal.
But in JIT?
In JIT, there is no pile. If the one part delivered to you is broken, the entire line stops. Everyone feels the pain. And because the pain is so immediate and so severe, the organization is forced to solve the root cause of that defect so it never ever happens again.
So everyone has to be perfect all the time?
Yes. Or rather, the system has to be designed to enable perfection. That means perfect supplier quality, perfect machine maintenance, perfect employee training. It raises the bar for everyone.
Let's talk about the physical layout, because that has to change too. The source mentions cellular organization.
This is one of the coolest parts of this whole thing. In a traditional factory, you have departments. All the drills are in one room. All the lathes are in another room. All the painting happens in a third room.
I'm picturing the spaghetti diagram in the notes. You have all these arrows crossing the factory floor as the part travels miles from department to get finished.
It's insane. The part might spend 95% of its time just sitting on a cart being moved or waiting in line. In a cellular layout, you completely rethink that. You group dissimilar machines together in a logical process sequence. You might put a drill, a lathe, and a polishing machine right next to each other in a U-shape.
So one worker can manage the whole sequence.
Exactly. One worker stands in the middle of the U. They pick up the raw part, drill it, turn 90 degrees, put it in the lathe, turn 90 degrees, polish it. Done. It's called one-piece flow. The part never touches the ground. It never waits.
And the feedback on quality must be instant.
Instantaneous. If the drill is slightly off, the worker notices it immediately when they try to put the part in the lathe 3 seconds later.
Yeah.
In the old system, the drilling department might make 500 bad parts before they get shipped to the lathe department 2 days later, and someone finally realizes they're all ruined.
Okay, I want to get into the technical weeds for a second because this is fascinating. There's a diagram in the source labeled JIT mechanics, the back flushing system. This sounds like plumbing, but it seems to be about how computers track all this high-speed flow.
Yes, this is a critical concept for any modern high-speed manufacturing system. Think about the old way. Every time a worker finished a step, they'd have to stop, wipe their hands, and write down on a clipboard, I finished 5 units. Or they'd have to stop and scan a barcode.
Which is the motion waste we talked about.
It's pure motion waste. It slows everything down, and JIT is all about speed and flow. So they invented backflushing. In this system, nobody tracks anything during the production process. Raw materials come in, workers build like crazy, and not a single transaction is entered into the computer system.
Wait, so for a while, the computer system thinks the warehouse is still full of raw materials even though they're being used?
For a short time, yes. But then a finished product, let's say it's a toaster, comes off the end of the assembly line. That finished toaster is scanned. The system says, one completed toaster. It then immediately looks up the recipe for that toaster, the bill of materials.
The ingredient list.
The ingredient list. It says, okay, one toaster requires 4 screws, 2 heating elements, and 1 power cord. Then it automatically deducts those specific components from the raw material inventory after the fact. It flushes them out of the system in one single transaction.
That is so smart. You eliminate all the tedious data entry during the process, just pure speed.
It is brilliant when it works. But just imagine the risk.
I can guess. What if the recipe in the computer is wrong? It says 4 screws, but the new design actually needs 5.
That's a huge problem. Or what if reality on the floor is messy? Let's say a worker is assembling the toaster. He drops a screw. It rolls into the machine. He doesn't want to waste time crawling around to find it, so he just grabs another screw from the bin and continues.
So he used 5 screws to make that one toaster, but the computer, when it back flushes, only deducts 4.
Exactly. The computer now thinks that lost screw is still sitting in the bin. Your physical reality and your digital reality have just diverged. Now multiply that tiny error by 1,000 workers over a 6-month period. Your computer says you have 50,000 screws in stock. You go to the bin, and it's empty.
And because you're doing JIT, you have no safety stock. The entire assembly line grinds to a halt. Everyone goes home.
Precisely. This is called phantom inventory. It's the ghost in the machine, and it's why backflushing requires incredible, almost military-grade discipline. You need 100% accurate reporting of any scrap. If you drop a screw, you must tell the system. If you don't, the entire house of cards collapses.
This transitions perfectly into our next section. Because you cannot run a high-wire act like JIT with a sloppy or undisciplined team. You need a specific kind of culture.
You absolutely do. This brings us to Section 3, culture and discipline. This is the human element. You can't automate your way out of this part.
And we have to start with the word Kaizen. We hear this word thrown around a lot. Continuous improvement.
Yes. But most people in the West get it wrong. They think Kaizen means management has a new initiative to make us work faster.
Right. The old joke, the beatings will continue until morale improves.
Exactly. No. True Kaizen, as influenced by pioneers like Shujo Shingo at Toyota, is fundamentally bottom-up. It's based on a deep, profound respect for the worker. It's based on the belief that the person actually doing the job knows more about that job than the CEO.
The real expert is the worker on the line.
Yes. The staircase visual in the source material shows this evolution. It starts with small, tiny, incremental changes. It's the worker on the line saying, hey, if I move this bin of screws 6 inches to the left, I save 1 second on every unit I make.
It sounds so trivial. 1 second.
But 1 second, saved 1,000 times a day, is over 15 minutes. Over a year, that's hours and hours of saved time, multiplied by every worker. Kaizen is about empowering that worker to move the bin without having to fill out 3 forms and ask for permission from 4 layers of management. It's about creating a culture of improvement.
But you can't just have thousands of people moving stuff around randomly. There has to be a framework, a shared understanding of order, and that's where 5S comes in.
Exactly.
Now, I see 5S posters in warehouses and factories all the time, and honestly, to an outsider, it just looks like a glorified cleaning roster.
It is so often dismissed as simple housekeeping. But 5S isn't about cleanliness for the sake of cleanliness. It's about readiness. It's about creating a workplace that is visually organized so that any abnormality, any problem, stands out immediately. It's about being ready to perform at the highest level.
Okay, let's run through the 5 S's because there's a lot of nuance here. The first S is SERI, sort.
Sort. This means going through every single item in a workspace, every tool, every file, every piece of paper, and distinguishing between what is absolutely necessary for the job and what isn't. And this is harder than it sounds. Humans are natural hoarders. Oh, I might need this broken wrench someday.
I might need this email from 2016 for some reason.
Exactly the same principle. Sort means if you haven't used it in a month, get it out of the immediate workspace. Put a red tag on it. If you don't use it in 6 months, get rid of it. Remove the noise so you can focus on the signal.
Okay, that makes sense. The second S, Satan, set in order.
This is the classic, a place for everything and everything in its place. This links directly back to eliminating motion waste. If I were to blindfold you at your desk, you should be able to reach out your hand and grab your stapler without thinking. If you have to hunt for it for even 5 seconds, that's waste. It means your workspace isn't set in order properly.
I think my desk would fail that test miserably. Okay, third S, say so, shine. This is the cleaning one.
This is the cleaning one, yes. But we have to ask the question, why do we clean? We don't clean to make the place look pretty for a visit from the vice president. We clean to inspect.
Explain what you mean by that.
If your machine is covered in a layer of grease and dust, you can't see a tiny stress fracture developing in a critical part. You can't see a small oil leak starting from a gasket. But if that machine and the floor around it are absolutely spotless, a single drop of oil stands out like a beacon. You catch the problem before the machine explodes.
That completely changes the perspective. Cleaning isn't a chore, it's a diagnostic activity.
It's preventative maintenance.
Okay, fourth S, seketsu. Standardize.
Standardize just means making the first 3 S's a habit, a rule. It's not we clean up when we have some free time. It's at 4:00 p.m. every single day, the last 15 minutes of the shift are dedicated to sort, set in order, and shine. It becomes part of the job.
And the final S, shitsuke, sustain.
The hardest one of all, discipline. It's about training, audits, and leadership commitment to prevent the natural slide back into chaos and clutter.
So we have the mindset, which is Kaizen. We have the organized workplace, which is 5S. Now we need to maintain the actual machines. This is TPM, total productive maintenance.
Right. Again, in a JIT system, a broken machine is an absolute disaster. TPM aims for the ideal of zero breakdowns. And the key pillar that makes this possible is a concept called autonomous maintenance.
Autonomous. That implies the machine is taking care of itself, like with AI or something.
No, not at all. It means the operator takes care of their own machine. Think about the difference between how you treat a rental car versus how you treat your own car.
Right. I treat rental cars, let's just say, much more roughly.
You drive it, you park it, you walk away. If it starts making a funny rattling noise, you turn at the radio and you don't care. That's the traditional factory worker's mindset. I just operate the buttons. The maintenance department are the ones who fix the leaks.
And TPM flips that script.
Completely. TPM says to the operator, this is your machine. You own it. This means the operator is responsible for the daily cleaning, lubrication, and basic inspections. They learn to tighten the bolts. They know what's normal sounds and smells. They can tell when something is just a little bit off, long before it becomes a major breakdown. They don't wait for a mechanic. They are the first line of defense.
It's all about ownership. Okay, so we have all these interlocking systems. How do we know if they're actually working? We need a score. And the source gives us a slightly terrifying math equation called OEE, overall equipment effectiveness.
This is the ultimate scorecard for a machine or a process. And it is brutal because it exposes all the hidden losses.
The formula is OEE equals availability, performance, X quality. I want to walk through this because the math is a little tricky, but it's really powerful.
Let's do a day in the life of a hypothetical machine. Let's call it the big stamper.
Okay, the big stamper. Let's say it's scheduled to run for a full 8-hour shift, which is 480 minutes.
Okay, but during that shift, it takes 30 minutes for setup and changeover, and it breaks down for 15 minutes. So the total downtime is 45 minutes. It was only available to run for 435 minutes out of a possible 480.
So 435 divided by 480, that's about 90.6%. That's its availability.
Exactly, 90.6%, which sounds pretty good, right?
Yeah.
That's an A in school.
Seems okay to me.
But hold on. Now, during the 435 minutes it was running, it's designed to stamp 10 parts per minute. So it should have made 4,350 parts. But the operator had to make a few minor adjustments, and the material feed jammed for a moment, so it only actually produced 4,000 parts.
Okay, so 4,000 divided by the potential 4,350. That's about 92%. That's its performance.
Right, 92% speed. Still looking pretty good on paper. But now we look at the 4,000 parts it made, and we find that 200 of them were scratched or slightly misshapen, so they have to be scrapped or reworked.
So only 3,800 were good parts. 3,800 divided by 4,000, that's 95% quality.
Okay, so now you, as the manager, look at these numbers. You have 90.6% availability, 92% performance, and 95% quality. You're thinking you have a solid 90+% efficient factory.
Yeah, I'd probably be giving my team a pat on the back.
But the OEE math is multiplicative. You have to multiply the three numbers together. So it's 0.906 times 0.92 times 0.95.
Okay, let me do the mental math here. 0.9 times 0.9 is roughly 0.81 times 0.95. I'm guessing it's somewhere in the high 70s.
It's 79%. Your OEE is 79%. You're not running an A operation. You're running a C+ operation.
Wow. The small losses in each category compound into a huge overall loss.
They compound dramatically. You think you're doing great in each area, but you're actually losing over 20% of your total potential value to these hidden losses. That's why OEE is so powerful. It makes the invisible waste visible.
And what do the world-class benchmarks in the source say you should aim for?
World-class OEE is considered to be around 85% or higher. And to get there, you typically need availability over 90%, performance over 95%, and quality over 99%.
Quality over 99%. That sounds incredibly high. But let's be honest. In today's world, is 99% actually good enough?
That is the perfect question to launch us into Section 4. Because for some things, like making toasters or garden hoses, maybe 99% quality is okay. But would you be happy getting on a plane if you knew that 99% of flights landed safely?
Absolutely not. A 1% crash rate would mean thousands of crashes every single day. It would be a global catastrophe.
Exactly. So for some applications, even 99% isn't good enough.
Yeah.
And that's when we have to leave the world of flow and enter the world of precision. Section 4. Six Sigma.
Six Sigma. This really feels like a shift in mindset. Lean and JIT were all about go fast, don't stop, keep the flow. Six Sigma feels much more like stop, slow down, measure everything, be perfect.
It is a profound shift. Lean primarily attacks visible waste. Six Sigma attacks invisible variation. It was famously developed by Motorola in the 80s and then scaled to incredible effect by Jack Welch at GE. The entire philosophy is about using data and rigorous statistical methods to eliminate defects.
We have a chart of the bell curve here. I'm having flashbacks to my Statistics 101 class.
The bell curve just represents reality. Let's say you're trying to make a part that's exactly 10 centimeters long. You measure 1,000 of them. Most will be very close to 10 centimeters, but some will be 10.01 centimeters. Some will be 9.99 centimeters. That spread, that distribution of results, that's variation.
And the sigma is a statistical measure of how wide that spread is.
Correct. And what the sources show is that most companies, even today, operate at what's called a 3 sigma level of quality. That sounds pretty good, but it translates to about 66,807 defects for every million opportunities.
66,000. That is a shocking number of defects.
It is. The goal of Six Sigma is to squeeze that bell curve so tight to reduce the variation so much that you only have 3.4 defects per million opportunities.
3.4 out of a million.
Yeah.
It's 99.9999. What is that, like 7% perfect?
It's 99.99966% perfect. It is as close to perfection as human beings can currently get in a complex process. And you don't get there by just trying harder. You get there with math. You have to prove, statistically, what is causing the variation and then systematically eliminate it.
The source gives us two different frameworks for implementing this, DMAIC and DMADV. I admit I always get these two mixed
It's
up.
a common confusion. The easiest way to think about it is this. DMAC is for fixing something that's already broken. It's for an existing process. Imagine your car is making a funny rattling noise.
Okay.
You use DMAC to find the problem. There's a rattle. Measure it. It only happens at 40 miles per hour. Analyze the data. The vibration frequency matches a loose heat shield. Improve it. Tighten the bolt on the heat shield. And control it. Check the bolt at every oil change. It is reactive.
Okay, reactive for existing processes. So what is DMADV?
DMADV is for when you are designing a brand new car from scratch. You want to design it so it never rattles in the first place.
Proactive.
It's completely proactive. Define the design goals. Measure the critical quality characteristics. Analyze the design options. Design the new process. And verify that the design works. You're building Six Sigma quality in from day one.
Okay, that clarifies it a lot. Now, Six Sigma people love their tools. They have a whole toolkit of charts and diagrams. Let's talk about a couple of the big ones. First, the fishbone diagram.
The fishbone, or the Ishikawa diagram. I love this tool because it forces you to think systemically. It prevents you from just blaming the nearest person. If a car won't start, our first impulse is to say the battery is dead. But the fishbone forces you to look at all potential categories of causes.
Man, machine, method, material, environment.
Right. Maybe the battery, the machine is fine, but the method of starting it was wrong, or the material, the gasoline, is bad, or the environment is too cold for the oil, or the man, the operator, didn't turn the key correctly. It forces you to widen your lens and consider all possibilities before jumping to a conclusion.
And the other big one is the Pareto diagram based on the famous 80-20 rule.
This is all about prioritization. In any complex system, you might have 100 different things causing problems. You can't fix them all at once. The Pareto principle says that very often, 80% of your problems are coming from just 20% of the causes.
The vital few.
The vital few. The Pareto chart helps you identify that 20%. It tells you, don't waste your time fixing these 80 minor issues. Focus all your energy on these 2 or 3 big ones. If you fix them, you'll eliminate most of your pain. It's about surgical focus.
Now, this brings us to a really interesting conflict. We spent the first half of our deep dive talking about lean, which is all about speed and flow. Now we're talking about Six Sigma, which is all about precision and perfection. Can you actually do both, or do you have to choose? Are these competing philosophies?
For a long time, in many companies, they were treated as rival camps.
Yeah.
You had the lean guys who were all about JIT and 5S, and then you had the Six Sigma black belts who were all about statistics and control charts. They often didn't talk to each other.
And
the result was suboptimal. The modern and much more effective approach is to combine them into one integrated system. Lean Six Sigma. The Venn diagram in our source material shows them overlapping for a reason.
So walk me through that. Why do they need each other?
Think about it. If you only implement lean, you might make your processes very, very fast. But if your process has inherent variation and quality problems, you're just making defects at a record speed.
You've become incredibly efficient at creating garbage.
Exactly. You're shipping junk to your customers faster than ever before. But on the other hand, if you only implement Six Sigma, you might create a process that produces a perfect product with 0 defects. But it's so slow, bureaucratic, and heavy with analysis that you go bankrupt before you can get the product to market.
So you need the balance. You use lean to create a fast, efficient process, and then you use Six Sigma to make sure that fast process is also a high-quality process.
Speed plus precision. That's the winning combination.
Okay, we've covered a tremendous amount of ground. We've cleaned the house with Lean, we've tuned the engine with JIT, we've perfected the aim with Six Sigma. But what if the house itself is just wrong? What if we're spending all this energy perfecting a typewriter factory and then the rest of the world has moved on to computers?
This is the moment of truth for any organization. Sometimes you can't incrementally improve your way to future success. You can't Kaizen a candle into a light bulb. The underlying technology or process is simply obsolete.
And this brings us to our final and most dramatic level in the architecture, Section 5, Revolution, or as it's formally known, Business Process Reengineering, BPR.
BPR. This is the scary one. This is the one that makes executives nervous. The definition in the source material is very clear. Fundamental rethinking and radical redesign of business processes to achieve dramatic improvements.
The source makes a key distinction between process innovation and BPR.
Yes. Think of process innovation like renovating your kitchen. You get beautiful new cabinets, quartz countertops, maybe you knock down a wall to create an open plan space. It's a significant improvement, but the fundamental footprint of the house is the same.
And BPR.
BPR is looking at the house and saying, this foundation is cracked, the wiring is 100 years old, and it's in a floodplain. Bring in the bulldozer. You're not renovating, you're demolishing to build something entirely new.
That sounds incredibly expensive.
Yeah.
And painful for the people who live in the house.
It is incredibly painful. BPR has a notoriously high failure rate, precisely because it's so disruptive. It usually involves significant layoffs, complete departmental restructuring, and destroying the old ways of doing things that people are comfortable with. But sometimes when you're facing an existential threat, it is the only way to survive.
The source lists 4 core components of BPR. Number 1 is fundamental rethinking.
This is the most important part. It means starting with a blank sheet of paper and asking the question, why? Why do we do this at all? A classic BPR case study is Ford's accounts payable department in the 1980s. They had hundreds of clerks whose only job was to match purchase orders to shipping receipts to supplier invoices.
And they tried to improve that.
They tried to make the clerks faster, that's Lean. They tried to reduce matching errors, that's Six Sigma. But BPR came in and asked the fundamental question, why do we even have invoices in the first place?
Wait, how can you run a business without invoices?
Well, the BPR team realized that the computer system already knew what they had ordered, the purchase order, and the receiving dock scanner knew what had arrived, the shipping receipt. If those two things match, why do you need a third piece of paper from the supplier? Just pay the vendor automatically.
They didn't optimize the invoice matching process, they deleted it?
They obliterated it. They went from 500 clerks down to about 100. That's the power of fundamental rethinking.
That is radical. Okay, component number 2, radical redesign, a clean slate approach.
The old saying is, don't pave the cow path. If you just automate a bad, inefficient process, all you get is a fast, bad process. BPR says you have to design the process from scratch based on modern technology and a focus on the customer.
Number 3, dramatic improvements.
We aren't looking for a 5% or 10% improvement here. BPR is aiming for quantum leaps, order of magnitude improvements, a 10x reduction in cost, or a 10x increase in speed.
And number 4, end-to-end processes.
This completely changes the organizational map. Most companies are organized vertically, by department: sales, manufacturing, shipping, finance. BPR says you should organize horizontally around the complete customer journey. For example, the order fulfillment process, which starts the moment a customer clicks buy and ends only when the box arrives on their doorstep.
Because the customer doesn't care about your internal departments. They just care about getting their stuff.
The customer's experience cuts across all those departmental silos. BPR says the company should be structured to reflect that reality.
So we've reached the end of the toolbox, and my head is spinning a bit. We have Lean, JIT, Kaizen, 5S, Six Sigma, BPR. It's a massive arsenal of methodologies.
It really is.
So let's try to simplify it. Let's bring it all back to the listener. I'm a manager. I walk into work tomorrow. I have a problem on my desk. How do I know which tool to grab? The source provides a fantastic manager's checklist. Let's walk through the scenarios.
Let's do it. This is the practical application.
Okay, scenario 1. My process is just sluggish. I have piles of paperwork everywhere. Work in progress is building up. People are constantly waiting on each other. Which tool do I use?
That is a classic flow problem. You have too much waste in the system. Your first move should be Lean and JIT. You need to map out your process, identify the 7 wastes, and start attacking them. Your goal is to increase throughput and reduce lead times.
Scenario 2. My workplace is just a mess. People can't find their tools or their files. Morale is low. It feels chaotic and undisciplined.
That's a foundational culture and discipline problem. You need to start with Kaizen and 5S. You have to empower the team to clean up their own house and then standardize the new, better way of working. You need to build a culture of order and continuous improvement from the ground up.
Okay, scenario 3. My customers are complaining about errors. Sometimes the product is great, but sometimes it's terrible. Our results are inconsistent and unpredictable.
That is a textbook variation problem. Your process is not stable.
Yeah.
You need the statistical power of Six Sigma. You need to get the data, use the tools like the fishbone and Pareto charts to find the true root cause of the inconsistency, and then implement controls to squeeze that variation out of the system.
And the final scenario, the big one. My competitors are eating my lunch, they're doing something totally new and different, and my old process just can't keep up no matter how much I try to tune it or improve it.
You have an obsolescence problem. Your current process is fundamentally broken or outdated. Incremental improvement won't save you. You need BPR. You have to have the courage to ask the hard, fundamental questions and be willing to start over with a clean sheet of paper. Don't fix the horse. It's time to design a car.
It feels like a complete diagnostic system when you lay it out like that. Flow, discipline, variation, or obsolescence.
It is, and it's important to remember the final quote from the end of the source material. Operational excellence is not a destination, but a continuous cycle. You never truly win. You use Lean to fix your flow, but that might reveal a hidden variation problem. So you use Six Sigma. You fix the variation, but then a new technology emerges, and you have to use BPR to re-engineer. It's a constant cycle.
That is both exhausting and incredibly inspiring at the same time.
That's the challenge of running any organization.
So here's my final thought, my challenge to you listening right now. Whether you run a factory, an IT department, a restaurant, or just your own household, look around tomorrow. Look at the invisible architecture of your work and your life, and ask yourself one simple question based on what you've heard today. Is it time to clean? Is it time to measure? Or is it time to blow it up?
That's the question.
Thanks for diving deep with us today.
A pleasure. See you next time.